Alright, in this lesson we are going to visualize and control the liquid control from HMI. Now this lesson is extended version of the last lesson. We have seen how to make a proportional logic. Now we are going to monitor that logic from the HMI. Okay, so if you can see that presently in my tank I have a very limited level, and which you can see on the HMI screen as well. This is what we are going to make in this lesson. I'm just showing you the final output. So right now this is in the auto mode, this is in the manual mode, right? In the manual mode both the valves are off. I can turn it on by giving some values to my draining valve, which will drain my input, my water level. You can see that this is getting drained. And if I turn on my filling valve, you can see that this is on. This is going to fill my tank. All right, so I'm controlling in manual mode how much I have to fill and how much I have to drain. So I can control my valves from here. This is my fill valve and that's my draining valve. All right, this is the manual mode. Here we are not controlling the level. Like in the last lesson we were giving some set point to control the level, but that's the manual mode. But if I go to the auto mode now by clicking this button, in the auto mode you will find that this will follow the set point. And here you have the error. Okay, so this will stop when this value goes to 9. And you can see that this is going to 9 and this valve is getting closed automatically. Okay, now if I change the set point, you can see that the error is 0, set point is 9 and the feedback is 9. If I change the set point to 50%, filling valve is closed and draining is on and level is decreasing, and this will decrease. When the error got 0, this will stop. The draining will stop. You can also see the draining is getting closed because this is a proportional control. Yeah. So this was the auto mode, and then you can quickly switch on to manual mode. In manual mode, whatever values you give to your draining and filling valve, that will be controlled. Okay, this is not following the set point. So let's see how we can create that. So in this case, I'm going to close this program because that I have created before creating this lesson, before creating this live session. So I'll close this one and I will close this program. And we will start with the last logic which we have made. So I will open the last logic. All right. So let's open this project which we have made last time. Okay. So this was our last logic. And here I have given you a homework. If you remember, I asked you to, let me open this one. The homework was to make a proportional control knob here so that we can change the gain of our control system from 0 to 10, right? But here I give you an option that you need to scale the value so that the gain changes from 1 to 10. Like here, this is 0 to 10, right? But in the program, it should be from 1 to 10, not 0. This was the home assignment. So if you see in the proportional logic, we have to make a formula to derive the proportional gain from scaling from 0 to 10 to 1 to 10. All right. So to make that scaling, we have this, we have a formula, and that formula says the scaled output. This is a standard formula. Whenever you are going to do scaling, you have to follow this formula. Okay. Now you can even note down this equation. This is very important. Doesn't matter which PLC you are using. If you want to scale your output, sometime, for example, we have this tank ranging from 0 to 300 centimeter. That's the range of my tank. That's the height of my tank. If I want to display the height of my tank, instead of, all right, I have closed my HMI. Instead of the 0 to 10, if I want to display the height in 0 to 300, then in that case, I have to scale my output. Okay. So to scale the output, we have this formula. It says output maximum minus output minimum multiply by input to be scaled minus input minimum divided by input maximum minus input minimum plus output minimum. Okay, so it's a kind of complex program. So in our case, the input which we have to scale was 0 to 10 and the output which we need was 1 to 10. So we have an offset of 1. So how to do that? If you see this formula, we have took a variable kpp. This is our scaled output. And it says output maximum. Output maximum was 10. This is the output we need. Minus output minimum, which was 1. So we put 1 here. And this is multiplied by input to be scaled. So I took this division here first. And then I multiply the whole thing with this kp. So this input to be scaled is here. Okay. Input to be scaled was kp. Kp was the input which we are getting from this potentiometer. All right. Then input minimum was 0.0. This is the input minimum. Okay. Divided by input maximum minus input minimum. So this division is here. Input maximum is 10.0. This is input maximum minus input minimum, which was 0. So I put 0 here. And overall plus with output minimum. So output minimum was 1. This one. So I put it here. So when you have this formula, you are scaling the range of 0 to 10 to 1 to 10. Okay. So let's just check this one first, and then we will proceed with the HMI. So I'm going to simulate this logic using PLC sim, and we are going to see the effect of factory IO in our coding. If you're not sure how this logic has been written in SCL, I would request you to please watch the last lesson. That is mandatory. So our simulation is going to start. I will load the program. Finish. And this I go to monitor it. Okay. Now you will see the kp is here, and I have to simulate this one again. This will be connected once you are running your simulator. Wait a second. Okay, we have two simulations on, so I have to close and start over again. Maybe this will help. Okay, now it is connected, and I will go back here. So yeah, now we have these values here. So this was our set point, and this is our kp. Okay, I can change the value of kp. Kp is my gain, and this is my set point, and I can show you set point. So set point was 2.5, and accordingly it will fill the level. This is the level meter. It will reach 2.5 and it will stop. This was the last logic, right? Now to see the kp, this was my kp, and if I make kp 0, but if I go inside and see the value of kpp, this is equivalent to 1. You can see kpp is 1. So inside the program, my gain is 1. But outside the system, my kp is 0. So we have scaled the value. So when I take kp equivalent to 10, you will see kpp is also equivalent to 10. This is 1 dot, and this is the power by 1. So 1 into 10 raised to power 1 is 10. Okay. If I make kp, let's say 4.6, so proportionally the value will be 5.17. If I make kp here 0, but here kpp is 1. So we have seen that the value of kp was 0 to 10, but the value of kpp was 1 to 10. This is how you do the scaling. And this is very easy if you do it in SCL. All right. So this was the homework, which I don't know, which you haven't done, or I don't know. So this is how you can do it. All right. How to scale the value. Now let's proceed with the HMI. What we have to do, we have some task of today, and I will open the assignment. The first task was, okay, what you will learn in this assignment: making HMI screen for level control. Second is tagging PLC addresses in HMI screen, visualizing and controlling the plant via HMI, and adding manual override switch. So these are the 4 things we are going to do. So the first thing it says, rewrite the KP, set point, error, feedback on HMI screen. So we have to make a screen and we have to read and write the values. So to proceed with that, let's open your program. And since it's an HMI, we have to add a new device. Okay, so go to add new device, and here you can select your HMI. In the HMI, you can select your HMI, whichever HMI you want to simulate. So I will use this display because this is the display which I already have in my lab as well. So we are using this HMI. So select your HMI, click OK. So once you click OK, there will be a wizard which will ask you for other settings which you need to put in the HMI as a startup settings. So this is the wizard. Now the first thing is you have to select the PLC. So select here. This is the PLC which we have already added here. So this will come automatically. If you haven't added a PLC, this will not come. So click on select, and you will see this has been connected to PLC automatically. Okay, this is the advantage of Siemens TIA. So click next, and these are the default settings about the colors of the headers. So I don't want to change it as of now. So I'm just going to click next, 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 and finish this wizard. So once I click on finish, you will have your HMI folder, subfolders ready here. Okay, now in this HMI folder, we have to create these things which have been asked here: KP, set point, error, feedback, and valve output. Okay, so the first thing I'm going to do is I'm going to change the background of this HMI because I don't like this gray color. I'm going to make it white. So just double click on the screen and you have this background color. I like the white color the most, so I'll just put white here. And this is the text, and that's the screen 0, because in the screen, if you see here, we have a screen 0 and that's the root screen. So this is the root screen. If I click on this button, I will move to screen 0. So we have 2 screens here. But since I don't need more screens, I can delete this button, and also I can delete screen 0 because we don't need more screen. We are happy with 1 screen. So here, this is the title. For the title, I can write liquid level control. Okay, whatever you wish, you can change the title, and I would like to make it a little bigger. 15 is okay. Now the first thing is we have to write the gain. Okay, now we can take some text from here. Okay, and for your convenience, I will zoom it so that you can see easily. Yeah, now it's okay. So here I will write proportional gain, which is KP. Okay, and what else we need? I will just copy paste and put the text, proportional gain, and then we need set point. Set point is the same thing which we were giving from here. Okay, we are replacing this panel with HMI now, so I'll delete all these buttons and potentiometer. We don't need this panel now. We have an HMI. So set point comes here, copy paste. Then I have a feedback. Feedback is the sensor. It's the sensor which is installed here. This is giving us a feedback about the level. Okay, let me see if you have a question. Okay, so after feedback, we have, what do we have? We have error. Okay, error will be the difference between your sensor and your set point. Okay, difference between set point and feedback is the error. So I guess these are the 4 things which was asked. And the valve output. Valve output we will use later when we make the valve here. Okay, so these are the 4 values. Now before making the numeric display, all right, we can do it here as well. Just drag this IO display, IO field. This is input output field. You just drag it here, and here this is your output. So double click this one, and you have the general properties, and mode should be only the output because this is just the display. That's not the input. And just for this appearance, I don't like its width, which is too much. So I will reduce it and make it like this. So that's the proportional gain. I will copy paste make it same for the set point, same for the feedback, and for the error. All right, now here the feedback was the output, so that's okay. Error is also the output, it's okay, but the set point was input. So you can make it input output as well, so that it also displays the set point if it was changed somewhere in the program. So input output is the best choice for set point. For proportional gain as well, you have input and output. Okay, so let me just drag it here, and to make it look better, I'm going to drag it here, feedback here, and error here. Okay, so these are the 4 things we have here. But the question is how we will link this numeric input to our PLC program. That's the question. So let's go back to the PLC program, because when you're programming your HMI, PLC and HMI programming goes together. So here, that's the proportional control logic. Go offline. Now, this ID34 was the set point before. So this ID34, if you notice here, was this one, which is a set point coming from here, the panel. Okay. So since we are replacing the panel, we do not need ID34 in the program. So if I say I remove this panel, I'll go to stop, I don't need these buttons. So we don't have any panel here now. So in the driver as well, there is nothing connected here instead of level meter, which is required. So in the set point, delete the set point. Sensor is okay. KP you have to delete, because these 2 values we are giving from the HMI. Okay, these 2 values are coming from the HMI, so we remove the addresses which were coming from outside. Okay, now the set point, I can give a data address. Okay, so let's take MD40. This is one data address which I am using as a real for the set point. Same in case of KP, you can write MD45. Okay, that's our KP. Now we have a drain value and filling value. These are the outputs which we will use later. So first we have KP and set points. So go to your HMI, set point was 40, KP was 45. Go to your HMI, select this tag, and then go to its tag properties, select this one, and make it bigger. And on the left hand side, you will see PLC tags, standard variables. So set point was 40, if I'm not wrong. So select this one, select this one. Sorry, it was proportional gain. Let me just check again. KP is 45. Proportional gain is 45. Okay. So going back here. We see some error here. There shouldn't be any error. I need to check. Oh, since our HMI is not connected properly, I think there is a problem. I may have to add HMI again. There is some problem with the connections, because once you verify that in your HMI connections, it shows your PLC here. All right. In the HMI, when you go on connections, it shows the HMI connection here, the PLC connection here. If you don't see that, it will be a problem when you're going to tag the addresses. Now you can see here, this is red. This red means the HMI is not correctly linked with the PLC. So to avoid that, we have to make sure our connection is okay. And this connection should naturally be okay, because the HMI is connected to PLC. But if we see the device and networks, yeah, this is not connected. So we have to maybe connect this one, add subnet. Here, let me just try this way. Should be some option here. I think I have to go back again. Some problem with the device configuration. Should be network. Let's save this project and open again. This problem comes sometimes with TIA because TIA is in a beta mode right now, and there are some bugs in the softwares, so sometimes we have to take care of that. Yeah, now it's connected, so I hope it should be connected here. Alright, let's see if I go online and it works. This is a very crucial part when you are linking your PLC with the HMI. Once you have a good connection, then things becomes easy. So this is the most troubleshooting part which occurs in the industries as well, when you are going to link your HMI with your PLC. So right now I'm going to simulate my PLC and see if it is being detected by the HMI. So PLC simulation is okay, but the HMI is still not connected, I guess. No, it's not. Alright, so I'm going to do is I'm going to add the HMI again, because that's the only thing you can do. If your PLC is fine and HMI is not connected, you have to add it again. So very quickly, I will just do it. Seems everything is okay, and I have to check connection. Yeah, now you can see that it says station, partner, and mode. Everything is okay now. Now we can proceed with our screens. Okay, so you can excuse the time I took for troubleshooting, but I hope you will learn that if your HMI is not working, that's what you can do. Okay, so very quickly, I will again do what I was doing before. Now for proportional gain, let's go back to main. For gain, I took MD45 and set point is MD40. So gain MD45, wait a second, yeah, general. So here, go back to PLC tags, MD45. So now you can see there is no red line because tag is linked, HMI is linked. Set point was MD40, so just go here, put MD40. All right. Now the feedback. Okay. The feedback is what? Feedback is my sensor. Sorry. Feedback is the sensor, this one. And this sensor, if you see in the driver, is connected to ID30. This is a level meter. So we will take this address. Okay. I can connect it. So in our PLC, if you see, the sensor is connected to ID30. So we have to take this tag directly. So this is the feedback, or if you want, I can write from sensor and select this one again, go to tag and see ID30 is where it's here. So that's the tag 5. Select this one. So that's how you tag, that's how you link PLC and HMI. Next is the error. Now that's interesting. If you go to your main block, you don't see any error here. So how to give a tag? The error was coming inside. Error was here. So how to take this error outside the main block? That's a different topic. So to do that, first we will take the outputs. If you remember, I explained in the last lesson, the inputs and outputs which you will take in this variable graph, variable table, that will be displayed in the main block. Okay. So when you go inside, take another block, and write error for display. Okay, the value isn't real. Now this was the error. We have to put the value of this error in our error display so that we have an output. So we will just write error display is equivalent to error. That's it. So now when you go back to your main block, this is shown in red because we have changed the block. Right click, update, okay. And now you have an error display coming out. So we can give it some tag. So let it be MD50. Okay, now we have a tag for error. So go back to your root screen and this is the error and give it the appropriate tag MD50. Okay, so that's how we have tagged all 4 numeric input-output display. Now the question was, we have to change its format. You can see there are so many decimals, but the values are coming in decimals. Okay, this is how the values are coming. To have it in decimals, just select this one, and we know that our range of values only from 0 to 10. So you change the format to this one, which is most likely suitable because the maximum value will be 10.0. So 99.9 is a good format. So you can see that the format has been changed. Similarly here, this looks okay. And here as well, this looks better. So all the 4 variables are changed to fraction on display with certain units. I can make it together. Okay, now all you have to do is you have defined these values. We have defined the data registers. We have to download this logic in the PLC first because we have made some changes. Go online, and you also have to download your HMI. So click on the HMI here and go to this one, start simulation. So once you click start simulation, it will open a window like this one, and let's open it here. Okay, so right now you can see that everything is 0. There is no set point. Fill valve is closed, drain valve is closed because everything is 0. So let's give a set point, but before giving set point we have to give a gain. So I'm giving it 5, and set point I need 5. So once I give 5, you can see that filling starts, and it starts filling the value, and it will reach up to 5. You can see that. This will, once it will match, filling will stop. Let me see if the volume of this is. Okay, now you can see that error is getting 0. So the same thing is happening now, but the only difference is we are doing it from the HMI. Now if I make set point 2, you will see value will decrease. And draining is on and the error is in minus, because we know that the value of error is minus when we are doing draining. And when it reaches to 2, this will stop draining. If you have any doubt up till here, you can ask me. This was the task 1. This is a proportional control. Now if I increase the gain to 6 or maybe to 8, the value will fill faster because the gain is increased. So now it's 80% filling, and filling will be done faster. Okay, this was the task 1. We have to just rewrite the KP, set point, error, feedback, valve output. I will do it later because this is linked to our second task. So this will be better if I do in the second task. So if you want, you can, if you have this page, you can write the code which I have entered in the PLC just for your reference. Second task is draw the tank, valves and pipes to visualize the process. This is very interesting. Animate the tank, pipes and valves if possible. Okay, we can do the animation as well in the HMI. First we have to draw it. So now comes the interesting part. I'll go back to my HMI here. So I need some space, so I will just make it here. Okay, first we will draw the tank. To draw the tank, you can use the bar option here, because this is more like the tank. So you can take the bar. So right now it looks like a bar, so we can change its appearance to look like a tank a little bit. So just double click this one and you will go to the properties. So first, let's talk about the appearance. In the appearance, there are some marks which I don't want, so I can remove it from here. And the border type, it's too thick, so I will make it like this. And the scales, I don't want any scales. So now it looks like a tank, more or less, right? And in the appearance, I would also like its background color to be white. I will tell you why I did that. So this is my tank, okay? To give its, now what will be the tag of this tank? This tank is replicating this filling, okay? And the feedback of filling is coming by a sensor, which is here, level meter, okay? So we have to give the tag of level meter here, okay? All right, so to add a level meter, just double click this one, and we know that our level meter is ID 30. Okay, this is ID 30 because in our driver, the level is ID 30. So you can relate from there. Okay, one more thing I want to say, that we are referring the software in which our input is ID 30. It's not ID 30 always. If you're using analog input, the addressing will be different. Okay, so you have to make sure what address you are using for analog input. Similarly, for analog output, it's QD30 here, but in real, it's not QD30. It's different, which is written on the manual. Okay, so you have to use the addresses which you are actually using in the plant. The rest, the process is same. Okay, so yeah, this is the tag, and the tag should be ID30. Give it the tag. So let's just simulate this one and see the results. Then we will make the valve and the pipes. So let's go back here. Now we have the tank and we have the HMI screen. You can see this is exact, this is not exact. Okay, one more thing I forgot. Why it is showing this level and this is at this level? Because we did not change the maximum scale. The maximum scale for our tank is 0 to 10, but here it's 0 to 100. So that should be 0 to 10. Okay, once you make it 10, again go to simulation to see the difference. Now it's okay. All right, so let's change the set point. Now this is decreasing and this is decreasing here. So this is how you can simply simulate your tank level based on what's going on the real process, by just taking care of the scale and tagging it with the PLC address. Now one more thing, that you will see this is a slow simulation compared to the real plant. This is a little bit having a lag. How to remove this lag, we will understand that in the last part of this lesson, how to make the values move quickly in and out. Okay, so let's make the valve now. All right, to make the valve, you have to have a library where you will find the valves. So if you see here in the toolbox, we have graphics. Here in the bottom, you will see graphics. And when you see graphic folder, there are many graphics. Like automation equipment, you have boilers, boiler, conveyor belts, ducts, valves, mixers, and here you will find some valves. 2 color filled, 2 colors, 256 colors. These are some valves available. But somehow I do not like these kind of valves, so I have created my own valve. All right, so this is also possible. You can create your own graphics. So if you see this folder, my graphic folders, I have made few graphics, like for pipes, for rollers, and for valves. These are my own created valves. So how did I make it? This you can do by, a Paint, Microsoft Paint. So if I show you my desktop, I have this Siemens add-on graphics. Here I have walls. So this has been designed in Microsoft Paint, and you can change the color. So I made 3 walls, red, blue, and orange. Okay. Similarly, I've made 3 pipes, which is flowing, not flowing, and partially flowing. So once you have these three files, you can do animations, and that's very interesting. So let's go back to our Siemens TIA. Now I need a valve here. So I know I have a valve here, but I will not add directly from here to my screen. First, I will go to my text and graphic list. Go here, and here this is the text list. We don't need text, we need a graphic. So click on the graphic list and click add new. This will be, let's say, valve. So once you have the valve graphic, below that select this one, valve. Below that you can define which graphic you need at what value. So here I will show you, I will go back to my graphics, valve. So we have three valves. So let's take the valve when it is closed. Drag it here. This is the valve when it is closed. Then the valve, by orange I mean the valve is partially on. Okay. Then by blue I mean valve is fully on. This is up to you if you want to display partially. You can also display valve off and valve on. But since it's a kind of animation, 3 frames animation, I'm using partially on. Now when the valve is off when the value of filling valve is 0. So I will put 0 here. And the valve is fully open when the value is 10. Okay. And the valve is partially open when the value is between 1 and 9. Alright. This is how you define the values for the graphics. So this graphic will appear if the draining valve is 0. This graphic will appear if the draining valve is between 1 and 9. And this will appear if the draining valve is 10. Okay. So what I'm going to do is, instead of taking 0 or 1 to 9, I can also take 1 to 7. 0.0 or just 7, and here I can take from 8 to 10, because even at 8 the valve is too much pressure, too much liquid is coming. This is just for reference. It's up to you how you want to animate at what values, but this is what I prefer. So next is we have to, okay, so valve is defined. Now go back to your screen. We need a valve here, so select your graphic from here. You will have a valve here. This is the valve which we have just created. So just drag it here. This looks a little weird, so we can change its appearance. Just double click this one and you will see appearance. And here I do not want any width. Also the style is solid is fine, and fill pattern is transparent. So this looks nice, better than before. So let me resize it and keep it here. So this is my filling valve. Parallelly, I can copy paste for my draining valve. Okay, let me make it bigger. So now the filling valve will have some address. That address will be similar to what we have here. For filling valve is QD30, for draining valve is QD34. So QD30 and QD34 we have to enter. Draining 34, QD is 30, so select this one. So QD30 is here. This is my filling, this is my draining, that will be QD34. Okay, so valves has been tagged. So let's see the result. Let's simulate that and how we are going to see this valves. There is one more problem which will occur in the screen, which I will explain you while showing you the scenario. Okay, right now fill valve is 0 and discharge valve is 0, so you can see that both are red. Okay, let's change the set point because nothing is happening. Let's go to 6. At 6 you will notice there is a problem. Valves are not showing, and why it's not showing I will explain you now. Let me just reach the value. Now you can see that this is shown. It was not shown when it was 10.0, but now it is being shown. I will tell you why. Because if you see in our PLC logic, the output goes beyond 10.0. Let's see that again. Here I'm going to show you the HMI. Now this is a filling valve, this is a draining valve. We know that the output is the range of the filling and draining is 0 to 10. But here, because of the PLC error and because of the gain, it goes beyond 0 and 10. Let's see that again. So I'll put maybe 2 here. So see, this is minus 32, this is 30. This is not in our range. So when it comes in the range of 0 to 10, you will see the valve. And this value of minus 14 and 13 is not it's not recommended. You should have the range 0 to 10. Now this range is here, so you can see the valve is here. So how to avoid that? We have to write the limits in our program. Okay, the limit says when the value of valve is more than 10, the valve should have the value 10. The maximum limit of the valve should be 10. Similarly, minimum limit should be 0. Okay, so to define these limits, it's a little bit if and else statement. I will write here limits. It's easy, but it's a bit of work. I will zoom it for you. Now go back to here. If you don't remember, you can use if else structure here. So if filling valve is greater than 10.0, which was the problem because the value was going to 32 and 35. What do we need? We need to make filling valve equal to 10. I'll just copy that one. So the moment value of the valve goes 11, this will be moved with 10. Problem solved. Similarly, copy that one. If the filling valve value is less than 0, if it is in minus, that should be equivalent to 0. Simple as that. So I will just copy this logic, paste here. Instead of filling valve, what we have? Draining valve. If the value of draining valve is more than 10, draining valve should be 10. So it's same for both the valves. Okay. If the value of drain valve is less than 0, drain valve should be 0. Alright, let's download this logic and let's see the results. Okay, now you can see it's red. Both are red. Go back to 5. And this is on, 100% on. This is off. Now when the value of this goes less than 8, this is going to be orange. And if this goes 0, this will be red. Okay, so this was the filling valve. The valve is going to stop, so this is red. Alright, this is how you animate it and define the limits. Okay, similarly, let's go back to HMI. We have to add the pipes. Okay, so for the pipes, again, I will go to my graphic list because pipe also we are going to animate. And here, graphic list, we have pipes. Now in the pipes, we have to add the graphics. So I have the graphic for pipes as well. This is when the pipe is empty. This is when the pipe is partially on. This is when the pipe is fully on. Okay. Now the value is 0 to 1. I don't need 0 to 1. 0 is okay. And the value I can use for the valve 1 to 7, 8 to 10. So this will be 1 to 7. This is from 8 to 10. Okay. This is my pipe. Let's go back to my root screen and have the pipe from here. Little bit you can change the appearance. Width 1, solid, transparent. Alright, that's good. So just place the pipe next to the valve. Make it look like that it's joining the pipe and the tank. So this is your own creativity, how you do that. So I will do it. I will actually bring it front. Yeah, it looks okay. Pretty much. So I will copy this pipe for my draining. And make it here. Okay. Again, bring it front. And also you can bring it front. Okay, so these are the pipes. Now how the pipe should simulate, it will copy the simulation of my filling valve because this is the same thing. If the valve is, how much valve is open, it will copy this one, right? So I'm going to copy the simulation for the filling valve to this pipe. So this tag will be filling valve was ID30, QD30. this one here. Also, well, this should not be QD30. This should be, in fact, 100% all the time, because the liquid is coming from the back. So this should be ideally 100%. So what we can do is just remove this one from here and just take a rectangle and just put it here, because the water is coming all the time. I hope you understand the point, right? And make it color of water. This is okay. This will actually follow the animation, because when this is open, then this will follow the animation. But here, this drainage valve should be controlled, so here will be the animation. This will be full. Okay, so I can copy that one, or this will be red when this level is below, or this should be empty when the level is empty. So what we can do is we will animate it differently. So this should be animated with the address of draining valve, so which is QD34, 34 here. Okay, I'll come back to this one later. So let's see the result. Okay, this I will do later. Now you can see that this is water is coming. We have to do the filling. And I'll click on, let's say 9. So by 9, this is fully open. So the level is, you can see the level is coming. We will show the water here in the later operation, later slides, because you have to ideally show the water is filling. That is the other part of animation. This is partially open, so the level is partially open here as well. This is a kind of animation. But when this is closed, so this will be closed. Okay, I hope this makes sense. For the draining as well, this is fully open, so this is showing liquid is flowing out. And when it is partially open, you can see the liquid of level also reduces. This is nothing, this is just the change of the graphics, which we call sometimes animation. And when it is closed, this will be red. Okay, but in this case, this should be blue when the level is more than 0, and this should be empty when the level is 0. Okay, so to do that, we have to make a different type of graphics. Okay, go to graphic, this, let's call it pipe 2. This pipe 2 has only 2 states, either high or low. Okay, so here I will take the pipes. It's either flowing or it's either empty. It's flowing when the value is from now in this case 1 to 10, and it is not flowing when the value is 0. All right, so this value depends upon the value of the level, not the valve this time, because if the tank is full or more than 1, it means water will come here in this pipe. If the tank is empty, water will not come here. So this is following the level. So go back to your general, select this one, and the input for the level was ID34. We know that from here. Sorry, ID30. Sorry, it will be ID30. Okay, now let's see the results. Oh, did I give the medium level? Let me check again. Sorry, I did not took the exact graphic. Type 2. Change its appearance. May I know whose noise is coming? Can you please mute your mic? Okay, this is here. Now let's check the simulation. Hold on a second. To 10 is flowing, 0 is not flowing. did I give the tag? Oh, I did not give the tag. So ID 30. Okay, now this is filled. So set point, let's put 2. So this is draining, nothing is filling. So this is the part how you animate the pipes, the tank, and the valve. Okay, do you have any questions? You can ask me. Now if I reduce the level to 0, set point to 0, it will go down, and once the level goes 0, even that pipe should be empty. Yeah, almost. So that's how you can show your animation of the tank. You can generally add more things here. You can also show the motor is running, it's rotating. So there could be many things you can show in your HMI screen based on the simple graphics, methodology, how you can change the graphics. All right. Now let's see the task. What was the task? So we have draw the tank, valves, pipes to visualize the process. Okay, one more thing we forgot. We have to show the valve output on HMI screen. Okay. To do that, we just go to your HMI, take IO field. Now we have to show the output. In that case, I will select it as an output. Okay, and I don't like its appearance. This is okay. Now this is the exact address of my filling valve. So you have to go to general, select the filling, and the filling was QD30 if I'm not wrong. This is the filling, and we have to change its format to this one. Okay. Similarly, I will copy that, paste here, and do that for this one. Here it will be draining, which was QD34. We can just verify that. 34 was drain, filling was 30. That's okay. So once again, go back to your HMI, simulate this one to see the results. So this is how you tag your HMI addressing to PLC addressing. This is here. Okay, so let's put a set point 5. You can see this is 10, this is 100% open, this is 0, this is closed. So once it reaches 5, you will see this value will change, which will follow the value here. Here you can see the value is decreasing, and here it's also decreasing. So now you're seeing what's happening in the plant in your HMI. You can also see the valve opening and closing, and so on. Okay, similarly for draining, I can show you again. This is the draining output, is just 10, which means 100%. And as the value is decreasing, this is decreasing and this is decreasing. Okay. Now I ask you that the simulation is having a bit delay, here the value is not decreasing as this one. So to reduce this delay of HMI, this is a setting in the HMI, and it's a very important setting. So if you go to the HMI tags, show all tags. Now these are the tags which HMI create automatically when we tag the PLC tag to HMI. Okay. So if you see these tags settings, here we have acquisition time, which is 1 second. This means HMI is taking 1 second to acquire the value from the PLC. Okay. If we reduce this value, HMI will quickly read the addresses from the PLC. So let's see what are the values we have. We have the values ranging from 100 milliseconds to 1 hour. Okay. So let's make it to 100 milliseconds. And if I check this corner here and drag it like that, I can override the values of 100 milliseconds here. Now if I simulate my HMI, it will be much faster than before, at least 10 times faster. So let's give the set point again, and you can see the result. Now you can see the animation is a bit faster. I mean, it's reading in faster rate. And you can also, this valve will decrease proportionally at a faster rate. This is just how you can increase the animation, make your animation more smooth. Okay. Similarly for draining, This is decreasing, and you will see decreasing here. It is decreasing. Okay. So yeah, that's how you can simulate, and this was what has been asked in task 2, to simulate everything. Now the task 3 is a bit complex. It says write a code for manual override button in the HMI to switch to manual auto mode and vice versa. In manual mode, provide 2 numeric inputs for filling and draining. So whatever happening right now, it's all automatic. We just give the set point, and filling and draining works automatically based on the set point and the feedback. Now we need a manual override. Suppose the maintenance engineer wants to do the cleaning, so he wants to empty the tank and he don't want to change the automatic gains and settings. He just want to, clean the tank or whatever it is. He wants to manually turn on the outputs. So to do that, we have to provide a manual button here, manual mode. Okay. So for that, there's a bit of programming involved. So first of all, we will go back to our PLC and open the proportional logic. Now, go back tab. Now here, if you see, the output is coming by these values. Our U is the output, okay? And these values should only come in the auto mode, okay? So this is a kind of proportional control auto mode. We need a manual mode. For the manual mode, we need a button. For the button, we need an input. For the input, we need a Boolean bit. So click on insert row, write manual button or bit, whatever. Manual button, and button is always Boolean. So put Boolean here. And here I'm going to write an if-else statement. Okay. Put it if else. So if button is pressed, so first I'll write if manual button is equivalent to 1. Now what should happen? In this case, whatever value I'm going to put in my HMI, I have to give a manual input, numeric input here. So let's define it here first. This is going to be my input. So select this one. This is my manual input, and the appearance. Okay. So this is my input for the draining. Copy paste. This is for the filling. Okay. This value should go into the valve. So go back to the programming. So if input is on, we have to define 2 more inputs. So in the input, I will write for filling manual, and also may I request you to please mute your mic because I hear some disturbances. So I don't know from which mic it is coming, so I request you all to please mute your mic if you don't have any questions. So filling valve and draining valve are 2 inputs. This is necessary because we are giving the values from input from here. This will be my filling input, this will be filling, this will be draining. Okay. So going back to my proportional logic. Yeah, if manual button is true, now what should happen? This filling valve should have the value from filling manual. Okay. So I will write here filling valve. This is the output. Should be equivalent to filling manual. Okay. Now why it's showing it red. Oh, sorry. This should not be Boolean. This should be real. Yeah. So you understand, if the manual button is on, whatever the value is in manual, this we will enter from the HMI, will go into the filling valve. Okay. Similarly, draining valve is equivalent to draining manual. Okay. This should only happen if the manual button is high. Okay. Else means if the manual button is low. in else statement, auto logic should work. So what I'll do is I'll just put this logic, cut it, and put the logic here. Okay, so if button is on, manual logic will work. If button is off, auto logic will work. Okay, so let's go back to the main block, update the block. Now you have manual button, filling manual, and draining manual. Manual button, so let's give a button m100.0. You can give any memory bit. Filling manual, let's give the address just like this one, MD55. Draining manual, MD60. So filling manual is 55, draining manual is 60. So go back to your, here we have to give 55. MD55 comes here and MD60 comes here. Again, we have to give the range. It should be this one. This looks okay, and this range is okay. Now we have two inputs. To differentiate the input from the output, I can also change its color. So the output I want to display, oh, you know, this is totally up to you how you want to display the background. I would like to give a yellow color. This has nothing to do with the logic. An input, I would like to give green color. Okay, this is what we did in the logic before in the demo video. So that's my input. If you still want some text here, you can take a text and write input. Okay, so that user is happy about knowing what is happening here. He will not be confused. This is the output, that's the feedback. Again, copy this input, put it here, and copy this one, and you can put it here or here, whatever you like. That's my input and output. Now we need a button because we took the button in the program, so you can take this switch for manual and auto. Okay, in this switch properties, in general, I will use it as switch with text, which is more appropriate. This is on and this is off. So in the on, I will write manual, because when you press, the manual will be on, and the off, I'll write auto. And now you can see the color is not okay, so I will change its appearance. The color of the text should be white, which makes more sense. Or you can also write manual mode, and here auto mode. Okay, this looks great. Now we have to tag this button. So the tag was what we give in the PLC, 100.0. That's the tag. Okay, everything is okay now. Let's see the results. So we have to download the PLC logic as well, since we changed the programming. I downloaded the PLC. Now it's the HMI. Oh, problem. There's something wrong. Wait. There is an error. What was the error? Okay, PLC is okay. HMI. Everything seems to work. Yeah, everything is okay. So go back. Now you have auto and manual mode. Right now it's the auto mode. It is working as it was working before. Inputs are 0. These are the manual inputs. Okay, everything is working fine. Once you go to the manual mode, now in manual mode, you have these inputs. Okay, so if I give the filling 6, it will start filling the tank. It does not depend upon the set point now. See, it is increasing set point. If I make it 0, filling will stop. If I want draining, I will input and put 9, and it is draining. Okay, and the output is the feedback. You can also do filling and draining together. In this case, tank will sustain the level because filling and draining is doing together at the same 90% rate. Now the interesting thing is, if I go to the auto mode, it is following the set point. So it will just go from 6.7 whatever to 8, and it will stop. So this is how you can add manual and auto override button in your HMI screen. If you want manual, just click the button manual. or auto, whatever it is. This is auto is the current mode. You can write a text over here, press to change the mode, which will help the user to understand what this button is doing. So maybe I can put a text here. Press to change mode, right? And this is taking a lot of space, so unbold it. Again, coming here. Yeah, perfect. Okay, this was 0, so yeah, this is closed. Now it is draining. Okay, one more thing. You will notice that this is 0 but this is 9. Output is 9 but input was 0. This was because I have given this input only. So as I said, I prefer input output. So make sure this is input output so that it also reads the feedback from the HMI for the last value. Now it's okay. Now the values are same. 3, 3, and this is draining with 5, so this will decrease the level. So this was the objective of this lesson today. We have seen how we have created the tags. We have seen how we have made the tanks, the walls, the pipes, how we have simulated that. And in the end, we have seen how to make a manual and auto override switch. And this is only with the help of SCL logic defined in the PLC. And this logic makes the operation very easy. You can see that in your main block, you have your own customized proportional control logic block, which also reads the set point, read the sensor, do the proportional control, also take the manual override and display the error values and output values. So it's up to you. It will stop. Okay. So you're talking about manual mode. We can also stop in the manual mode. First, let's see in the auto mode.
No, sir, but
Yep. You can see in auto mode it's
in
stopped.
the auto mode,
stopped.
but by the mistake, some mistake in the PLC or some
Okay.
HMI.
You mean
so
to
if
say
the filling valve is stopped,
alright. You mean to say if in
Yes,
the auto
sir,
mode
you can
there is
proceed.
some problem in the PLC and the valve is not stopping, how to stop it? Is it your question?
Exactly.
Alright, you see in the auto mode, let's go back to the logic. In the auto mode, suppose the auto mode programming is okay. From the PLC, output is going 0 to the valve. But in the valve, it is getting on, then it means the PLC analog output card has been saturated. By saturated, I means even if the value from the PLC is going 0, it is showing the value 10. This is called saturation of PLC. This is a hardware problem. In that case, what you can do is you can only read the level of this tank, and you have to add an extra maybe relay to turn on and off. For example, I will show you that in maybe PowerPoint. It's a good question for protection of your system. So let's
because we are dealing with it.
All right, let's say this is a tank, and you can actually use an on-off type of valve as well instead of relay. Relay is not a good idea. This is a pipe, and then we have a valve. Sorry. Suppose this is your analog valve. Then you have to add another valve here. This is a digital valve. You don't need another analog valve because analog valves are very costly. So you can take, where's the text? Insert text. Take a digital valve here. Alright, now you understand this analog valve was getting the value 0 to 10 volts. Alright. And this digital valve is only on-off type. Now in the proportional logic, in the auto logic, you can add one more line. Let me just show you in the program. This was the auto logic. You can write an if-else statement. I cannot write here because I don't have a digital valve, but just for the comment, if the level, which was ID30 was our level, which let me see, the sensor. So if sensor is equivalent to 10, then what should happen? The digital wall, I'm going to write here, digital wall is going to 0. Okay, this is the wall, this one. If this valve goes off, then there will be no filling, even if this is on, because the water is coming from here. This is the main supply of water. So first we have a digital valve, we have to turn it on initially, then we do the auto mode. If auto mode goes fail, if this valve is failed, okay, this is not working anymore, then this will be off based on the level here. So when this goes off, there will be no filling. Are you getting me?
Yes, sir. Yes, sir.
So
Okay,
you
sir.
have to
This
have
is a
an
good
extra
idea.
digital valve for protection. Otherwise, if everything is okay, this will be on and off based on the logic. But if there is a problem with the valve, you can turn it off. Even if
Alright,
the
sir.
level reach 100%, this will be off all the time. Even if the valve is working, this will be off and on all the time. But if this goes fail, this will be off. So your process will be saved. Do
Okay,
you have
sir.
any other question? Any one of you? Or should we close the lesson?
No questions from me.
Alright, I see some message here. Have you solved the previous problem to show level reading in the factory? Of course, we have shown it. Gaurav, I think you were late. We started this lesson with the homework which I gave you. So this has been resolved. I'm sorry you were late if you haven't seen it. Can we get a video of this session? Neha, if you're enrolled in the course Siemens S7 1200, you can ask the instructor in the NFI, so he can give you the access. Then you can see the video of this session. Otherwise, this will not be in the Facebook or in YouTube. So Gaurav and Neha, if you can hear me, I hope I answered your query. And with that, I would like to thank you all for joining me. And have fun. Have a nice day. I'll see you in the next class. And the updates of the class, next class will be on the Facebook. If you do not see an update, it means there is no class. But if you see an update, it means some class is going to happen. Okay? All right. Thank you so much and have a nice day. Ciao.